Okay, welcome everybody to Euler hack number 11. Today, I don't know, should I make very big introductions? I think you all know how it works.
Yeah.
So let's just start with the first problem, I guess. Again, you're being recorded, at least your audio, just to be explicit about it.
I didn't know that.
Yes,
Yeah.
not your face, you won't be, unless you tell.
I got notification
And what
of
did you do with the audio afterwards?
It's being streamed onto the YouTubes,
Okay.
so if you want to review anything, you can do that.
Is someone watching that?
I don't think so. Maybe posterity will care.
Problem 7.
Yes.
we can just use C event.
Okay. Formalities, more or less, I guess. You can pick a new one already if you want.
Oh,
Let's do this first.
I mean,
I think with C if we will pick the
okay.
10,000 and then we'll have to.
But I remember at some point someone said it makes sense to do them in order. This
Yeah.
here it makes sense. It's like here you learn how to do primes in a
So we could
Clever way.
we could try and make this interesting, because usually whenever I'm asked for primes, I just copy and paste something from somewhere else.
Yeah.
But maybe that's too much of cheating this time.
Yeah.
So we could just get def primes up to n, and for I in range 2 to n plus 1.
Maybe.
And is prime, I guess we can just add it onto some kind of list. And here primes.
Oh, you don't need to find all the primes. If you just want to solve the thing, you just have to count how many you have, right?
The 10,000th prime.
Yeah, you just need to count it.
Well, but we need to know what previous primes were there to determine whether or not the.
Depends, how
Yeah.
you want to implement it.
Yeah, we should keep them. But we have separate function is prime.
Oh, is prime? You want to do that? You don't want to do prime sieve?
I don't know. Maybe
I mean,
if you don't want it to cheat, we should also write the this prime or not.
I mean, it doesn't have to be a function, does it? I mean, it can be just for, so,
Yeah.
I guess we'll call this prime sieve. Is IE or EI?
I think
I was just wondering. I don't know.
IE.
Yeah.
I think, yeah.
Okay, so we can say is prime to start with is true, and this will be the case so long as we don't find any prime in the current primes. So for p in primes, if candidate mod prime, I guess let's call it, why not? 0, then it's not a prime. Is prime false, and I guess break. If is prime, primes append prime candidate, and I guess what else? So the first optimization is, I think, jumping by 2. It's like the minimal optimization you can do, I think.
Here we want to check the 10,000 first prime, or
here we want to check we want to get some number of primes and then we just get the prime out of it, I think. Does that look okay to you guys?
maybe so we can only go up to SQRT and
Right. Here you mean, right? Square root of the candidate.
no, the square root of n plus 1.
Well, it depends on how you define it.
Because if
we want to get all of the primes up on, I mean, this can mean either so many primes we want to get. This can mean we want to get all primes lower than a certain number, or it could mean actually that's the two things.
here we like return if the number of prime list is 10,000.
Yeah, let's do that. Okay. Num primes, and then what do we need to do up to? Actually, we probably just go.
Every while true.
Yeah.
And or while len prime less than 10,000.
Yes, right. And then we just at the end can.
Yeah, the for loop for candidate, that's what I meant by we define a function is prime. So that's the is prime function.
This part would be this prime.
No, we checking for prime in primes. Oh.
We check. So we have the candidate.
Yeah.
And we check if it is prime.
Mm-hmm.
So I mean we can.
Oh, we should.
Clear enough at least. Candidate said primes no. So this is, I think, where the optimization would be. We're probably checking lots of primes that we don't need to.
Mm-hmm.
But maybe this is enough. So let's see. Primes up onto 10,000.
We do it for small number first.
Okay. And I guess let's get the 100th prime. See if that's the correct. Hello. So that is the 574. So that's at least correct. And I guess let's just yeah. It doesn't look
10,000.
Oh, it's quite slow for just this low number of primes actually. but I guess it's enough.
This last one is enough.
How are you guys feeling about this solution?
Why is it candidate is equals to +2?
I mean, you could start differently. Sure. This is, I don't know, a micro optimization. So this way we only have to do half the numbers, check half of the candidates, because everything which is.
Oh, okay. Okay.
But in principle, I mean, it's just the first possible optimization you can do.
And in the primes, we can only list one number, like primes is equals
Well, you could start anywhere. You could do 3, 5, and then you can start at 7, for example.
Okay. Number of primes. Okay. You're just defining giving some value so that you can go to the while loop, like length of primes is less than.
Yeah. We can also, I remember it, we'll just do this. Also, we don't have to check every prime here. So we could get square root of
the length of the
what is, I guess, math square root.
or to the power of half.
Yeah, let's do that. And I guess we do the integer. It doesn't matter, actually, do it. So if the prime is greater than the square root of that, then we know everything that follows will not be one of the candidates. And then which number?
102. I guess you don't need the copy.
Oh no. Does not seem very complicated technically, does it? Oops. Actually, now that I think about it, my linear algebra is not so fresh, I guess.
More, I think, geometry than
Pardon?
it's like more geometry.
Yeah, yeah.
Stuff. Yeah.
Is it? Oh, is that not linear algebra?
Yeah, no.
Different name for it.
Linear algebra is working with matrices.
Oh,
Yeah.
well, that's points. I guess points are made to. Well, I don't know. Okay, so I guess lines. Did I not save this? Oh, shit. So welcome to.
I have a Python question. Is it actually a problem that you don't close the thing afterwards?
Who says I don't close? What?
You open the file, but you never say close file.
Oh, right.
So I usually put it in a with statement.
Yeah. I mean,
Probably not a problem.
yes. I mean, we can adhere. We can. Yeah. Sure. Strictly speaking, I mean, it's a reference counted thing. So as long as there's no reference to it, it will. Once there's no reference to it, it will be closed, at least in CPython. But since this is running in this IPython notebook, there probably is a reference to it somewhere. So it probably is still open as. But, okay. I think we do this. I guess I did the wrong. Is that what they said the structure is? Containing coordinates of 1000. Find the number of terms which. Oh no, it's just. Ah, right. Okay, pardon me. So it's always 3 points. Okay. So the first two, then the second two. So this is our triangle. Okay.
I think I have an idea, but I'm not sure.
Yeah.
So, like we have this Cartesian. Let's assume this is 1000 and this is 1000. This is.
Yeah.
So we have like four areas.
Quadrants.
Yeah. So I think at least every point should be in an area to have an
Yeah.
to this center can be included in the
But that,
three
F
different areas.
point. It satisfies also for the second point, no? What
yeah.
you said. But the second triangle doesn't contain the origin.
I didn't check. So this one is. Oh yes.
Yeah.
Can be something like this. Right. Can be something like this.
Exactly, yes.
At that point, we should calculate the distance between distance from the origin to the point in between should be like should be less than
Oh. Okay. Let me think about it.
If the point, I think the idea with calculating the distance to the origin is good. So if we have that,
Yeah.
we can come up with some criteria.
The distance to the origin, okay, then we do some kind of right angle triangle stuff, I guess. So O as in origin. I don't know, is there a better one?
And I guess the distance to the origin needs to be smaller than any of the distances between the 3 points.
How?
Good. That's not bad.
Origin, yeah.
The distance from, let's take the first example, the distance from the origin to A, the distance from the origin to B, and the distance to C
Yeah.
should always, so these 3 distances should always be smaller than the maximum distance between 2 points. It somehow makes sense, I'm not sure if capture all cases.
Yeah, that
This distance from origin to these 3 points should be less than
Yeah,
all of the sides.
yes.
yeah.
Yeah.
I think that might work, yeah. I can't
Because
think of a case where
it's-
it's not where it's not true.
If the well, in this case it definitely works. If the
So-
points would be down there, it would also work. Yeah.
So yeah. So in this case, A would be farther away from origin than from C. So it's not so origin is outside.
Yeah, that's true.
Yeah. So in this case, it wouldn't, I guess. I think it might work. No? You have
We
a
can
different
see.
idea?
I can have, for example, like distance to every point should be less than the distance from points from each other. For example, from O to A is less than A to B and less than B to C.
That's what he's saying.
Yeah, that's the idea.
Yeah,
I'm not
thinking
sure if we
about
cover all
like
cases.
I can't think of
counterexample.
I can't think of an example where it would not be the case.
Actually, what is the criteria? I could not
Go
assess
list.
what is the criteria of being origin?
The origin has to be inside the triangle, so the origin is here, and so if it's so we count the triangles for which this is the case. So here my ASCII art fails me, but maybe I can draw. I think you can picture the line here. So in this case, this would be a triangle we want, you see, and if it's like this, then the triangle is outside, the origin is not inside the triangle. So this is one of the triangles that we want to not count.
The origin is 0, 0, 0.
Yes.
Right, yes, yes, yes.
And what was the idea that you came up with?
The idea is that we compute the distances from the origin to the 3 points.
Right.
And then we look if this distance is always smaller than the
Distance between.
distance between the points. Yeah.
Yeah, between, so if there is,
To the origin, definitely somehow.
Yeah, origin would be from 0, 0. Yeah.
collection.
But would it work if the triangle is very small and doesn't contain the origin? But if there is a very big triangle but contains the origin, still the distance would be more, no?
What would that look like, the triangle, for example? Can you?
Maybe I didn't understand what you said, but for example, we have a very small triangle which does not contain the origin,
Right.
and let's say a very large triangle which contains the origin. Would the distance still, would the distance idea still work, or maybe I didn't?
Let's check. For this example, it should work. For this example, maybe not.
What?
Oh, it works for
the small one.
For the small
Well,
one.
for the small one, this point is further away from the origin than from this and
Yeah.
from this.
Yeah.
Well, at least from this.
Yeah.
But not from this, so maybe we have to refine the logic a bit.
Well, we not from what? What?
This distance from, I don't know, these 2 points
Yeah.
might be longer than the distance from origin to this one.
Maybe
right?
any point from.
But okay.
No, we have any. This
Yeah.
or
Yeah.
this.
Yeah.
So if any, like from A to this ABC of any AB or AC is less than OA or only OA, so it's true. So this is like we don't continue because we have a distance less than AO.
Yes.
Yeah.
Maybe we're doing it, but maybe we're missing a case where a triangle is. Yeah. Okay. So let's take this one. So,
We can also try.
but this is included.
Like something like this.
No.
No.
But the distance from here to here is shorter. The distance here to here.
Or we can just try. with-
No, from here is less than
I think
this and this.
I think it might work. I don't know.
So we continue with other angle.
Angle. I'm not doing anything with angles.
No, with another point.
My magic fails me. Okay. Yeah. Where did I go wrong? Oh, right, star. Very good. Okay. So let's just make an assertion. So the distance from point with 0x and 1 should be, and point.
What is the point? Where did you have it from?
I just created point x and y.
Oh, okay.
So point 0 and 2, I guess this should be equal to 1. So I guess that works. Schade. Okay. Let's see.
No, it will be equal to a squared t. No, it's equal to 2, yeah.
So right-sided triangles, how do they work again? So a squared, b squared and stuff,
Yeah.
I think. So well, a is
Maybe p1x, yeah, minus p2x to the power of 2.
where's the right? Oh, wait a minute. Where's the right?
Plus.
Okay. We're getting it to.
Yeah, maybe we can do plus directly. Yeah.
Interior means
To the power, all to the power
area
of half.
the triangle. That's the interior. Yeah.
I think maybe we don't need to compute
Exactly.
the square because it will be equal or like distance squared will be equal to each other.
Yeah.
Well, we wouldn't have to do the square, yes. The distances will all be proportional.
Yeah.
So we can just say square distance or something.
Yes.
Yeah, there's some file. Which you
But I don't know what the square distance is off the top of my head for this, so I'm just going to do.
that are like this.
I'm going to do it anyway. I don't think it will hurt. Yes. Okay, so I guess what is the typical example is 2, 1. Yeah, okay. And to the origin, I guess we can just do origin O. My computer not reacting. There we go. So we want to the origin and to the other points. Yeah. So ODist, I guess. Is there any elegant way to do this? Or should I just write out each individual thing?
What are you computing? If AO dist bigger than AB dist or AO dist? Okay.
Return false.
Is it supposed to be AB dist in both the cases or AB dist? If in what is
It's the same AC or CA.
Okay, and now I guess we need to make sure we don't make.
Oh, maybe we have a function and then we have ABC, then we have BAC, then we have CEB. We don't like repeat.
Def. I guess is origin farthest, and then we have P1 and P2 and P3, and we're comparing this to this and the origin, I guess. Oops. So we're always comparing P1 to the others. No, I guess we ought to call it B and C. No, that's not.
P2 list.
So there, I guess it's oldest. And I guess we can just do return. Is that clear? When my computer is less laggy. BAC and CAB. So or make sense approximately. Seems almost not worth having a function for. So try contains origin is true when the origin, well no, this is wrong. So if none of these is true, is that
That's our current guess.
okay? So I guess what are we doing? Let's I guess maybe it does make sense to have it as a function, just for testing purposes. So let's just copy this out. So does the triangle contain the origin? I don't know, what do we do? Something that we know contains the origin.
ABC contains the first example of.
Okay.
The first contains it, the second not. So just the first two examples from this file.
Boo. Boo. Okay, where is it going wrong? So CAB, supposedly the origin in this is further away than, so the point in this will, okay, C is further away from the origin than from either of these, supposedly. guess we'll have to draw it.
Yeah.
Yeah, something like this with the edges. Yeah, C would be something like this. A minus. Like the middle and B is Can we go back to the definition of further?
Of which one?
Is further.
Okay, forget about it. From is further, or is origin farthest, yes.
Yeah. Would return false.
We can print, I guess,
From
the...
O to C.
No, it's not helping. Oh, Jesus. Well, okay. If the magic doesn't want to play with us. So for A, the origin is this.
Yeah, one of them is not.
So supposedly
But at least
supposedly A is further away from C than the origin.
yeah, but B is not. OC is greater than CB.
OC is greater than CB.
I think our condition should be at least one of the point should be further, not both.
But that is what our condition is.
But
Isn't it?
oh,
Any of them should be further.
but which one we have? Which point? The both point are.
So the point C is supposedly further away. So this is the distance to the origin, and this is the distance to point B. No, to point A. To point A. Actually, wait a minute. Because I call it multiple times. Okay, yeah, it's okay. That was true. Yeah, it just does it multiple times.
So the first one is distance from OC, from work.
Yeah, cool.
Yeah. So it's in the middle, it's not both of them. One is bigger, one is less. Why we... Yeah. One is bigger, one is less. So why we have both?
Oh,
We said at least one is bigger. If this distance is less than this distance, it's okay. At least we have this distance is bigger than this one.
Are you sure?
Yeah. It does. Yeah. So this is C, this is A, this is B.
Yeah.
So here what we have this BC is less than OC, so that what makes the test fail. But at least we have AC is bigger than OC, so that's it. No matter if BC is bigger than OC, so we don't test for that. So one of those is.
Okay.
And what is?
But are you
we
sure?
testing currently?
Okay, I see. Well, we're checking if anything is further away from the origin. But, I mean, I see now why this solution doesn't work. But I'm not sure that just saying that either of them only one of them.
At least one of them is.
I have another idea. I'm not sure if it works or not. Just give a try.
Yeah.
This is a perpendicular.
Yeah.
This is a perpendicular. And one of them is a line of something like this. This perpendicular to this line is not inside one of the line. Then it's not sources. It's not inside. It's difficult to program.
But the line starts at the outside, I guess. So where are you? Oh, you get the normal to this point, I guess.
Yeah, to source. If it's inside this line, if it's inside of three of them, then it's the source is inside it.
Yeah. If you can, yeah.
If one of them, if one of the perpendicular to one of the line, the source is outside. Something like this.
Yeah.
Maybe it's difficult to program.
Well, if you know offhand the formula to calculate a normal off of a line which intersects a point, I don't.
Oh yeah, maybe it's complex. I'm not sure.
It exists. I'm certain of it. But okay, well. So Atif, you're saying that if one of them is not the farthest, it's okay?
Yeah.
Can we think offhand of counterexamples where that would not be the case, where we would get false positives?
And the thing is, if this distance is less one of other one, so we make sure that O is inside the triangle. Because we also check that, for example, from OA to is also less than one of the other segment of triangle. At least one of them.
Wait a second. So can I just? Is this the triangle that we're looking at?
Yeah.
So O is
But
further.
B is in the left bottom side. Yeah. Because one negative, positive, negative, negative. B is negative. Yeah.
So something like
No, maybe we can put C in the corner here. So
well, as long as the
this is like approximation to
yeah,
what's here.
that's what I'm trying to. Okay, wait a minute. So would you agree that? But it doesn't satisfy the criteria yet. Okay, so where do you want to have?
No, this is totally the same as the example.
So if this is the same, then that means that B is further away, is not further away from O. Which, yeah, B is not further away from O. Oh wait, no.
This example should like make this distance smaller. Like C, maybe we can make it here and B still here. Yeah. We can make C closer to B, so this distance is less than this distance.
Okay, so something like this.
We want this distance
Yes.
less than this one. So we make B and C together. Yeah, something like that. Maybe could be.
No, it's okay, as long as that's satisfied. Yeah. Okay, so in this case, O is further away from B, right? Fair enough.
Yeah, at least we have AC is bigger than OC, so for that point C it satisfies the condition.
Okay, let me just let's draw a different triangle, DEF. So if we have, if we accept that either of them, okay, it should be outside, right? So here I want to draw one that is outside, where the origin is outside. So if you're saying that either one point can be outside, is that what you're saying? One point can be further away.
Yeah.
So in this case, both of them are further away. So if we're looking at D, in that case, both E and F are closer to D. So we found one that, yeah, okay. Maybe.
So if like we have a distance here, if we have a distance OD is less than one of those, so we make sure that we are making these points further, so O will be inside the.
Yeah. Yeah, and actually that makes it's almost intuitively makes a bit more sense actually. If we position ourselves at any point and we look out to the others and we see that the origin is further away from both of them.
So the origin will not be included in that area, which
Yes.
is that triangle. It's not that.
Can anybody think of counterexamples? Can anybody prove that this would be a valid solution? Okay, well, it's easy enough to implement. So, what is it? It's this thing. And I guess is the change, isn't it?
False. We do that.
So if we're positioned at D, both this and this have to be further away.
Yeah, it's further, yeah, both of them. Yeah. The false statement should include the both of them should be further, otherwise it's not further.
Both are further away.
Yeah. So we do and statement. Because we are collecting the false stuff. Is origin further. That means O is not inside the triangle. And then we'll do not and or of all the conditions. We can give it a try.
I don't think this works.
Me neither.
Look at the ABC. C relative to B is closer. Well, okay, wait a minute. But it is inside the triangle. But I can think of, okay, but yeah, maybe it will.
Yeah, here further should both this is superior to this.
So the assertion holds.
Maybe we can test the other triangle. Yeah. Certain.
So supposedly this one is considered to contain the origin. Isn't that, that's what it said, isn't it? Yeah. No.
I think the problem is if we do it like this, we are kind of drawing circles around for the distances, right? So imagine
Yes.
this is our triangle. Whatever. Don't care where the origin is, could be anywhere. What we test is we're drawing circles around each point, then say, okay, right?
Yeah.
Because we say it has to be minimum one of the distances.
Right, yes.
So we're drawing circles, but actually
Then check if
this
the
would be
origin
another
is one.
circle and the other one would be like this. And our test is the origin contained in all of the three circles, right? Yeah, but then it's not correct, right? Because the things contained in all three circles is this area.
Well, I'm not sure that's what we're exactly testing, but I think it may be the right view of it.
Definitely, when we compare these distances, we're kind of drawing circles.
Yeah.
But somehow the area is not bounded by in a circular shape, but straights somehow.
Yes.
Right?
Correct. Okay, fair enough.
don't have a solution.
Maybe we do have to start drawing lines from something.
I think I get the counterexample from the x, y, and z.
Make something marginally straight. What if we consider the triangles to the origin and that the area of them is smaller, always smaller than we don't actually, it's not so. One good idea that you just had, Wolfgang, is to completely ignore the axis. So we just talk about a point being included in the triangle.
It makes it easier to draw.
Yeah, but besides that, yeah. So if a point is outside of the triangle, then one of the triangles formed by going to two other points will be larger than so if we draw an axis around here, then we know that this line has to cross. Every line has to cross, every axis has to be crossed once.
Yeah, this is happening. We can also experiment more. Each axis should be close to one side.
Yeah, makes sense. I'm just thinking if there's a way to do it like this.
We can compute the line formula actually. This is not
Is it? Yeah. Well, we draw every line and we mark every axis that we crossed, I guess. So we see point AB. So we see if that line crosses. Well, we mark the axis that line crosses, and then we check off. Well, actually, it can cross multiple lines, yes. Yeah, but this is the solution. What is this? So, if a point falls within the triangle, if the axis of that point, every single thing will be crossed. So actually the quadrant idea was not so bad. Well, maybe it's the same. No, it's not the same. But the quadrant idea, so it's just the axes, right? Every axis, positive and negative, has to be crossed, and not the quadrants. So what that idea was,
If we stand, for example, AB with first we cross this one. We want to make
if you
sure.
move this up, and it will not cross this one at least. So the rest should be crossed.
yeah, every axis has to be
One of the lines has to cross at least 2 axes, and also the other line has to cross at least 1 axis.
Each.
Well, I mean, we could draw. Let's see. If we draw this point, actually this point is already. If we extend this, so this AC would cross 2 axes, and this would cross 1 axis, and this would cross 1 axis. So we can't just count the axes. We have to mark every single one of the ones.
So we just have to check if we crossed all of the 4.
Yeah.
So we need a function that for given 2 points computes the axes that we can cross. And then we have a set, and then we check.
Axis plural.
Yeah.
You can just cross the positive and negative axes.
Yeah.
This is crossing this.
And then how we
That's a good point. Maybe we can, maybe we can get away with counting.
Yeah, like for something to cross, it
Yes.
has to cross like x and y,
Yes.
and the other has to cross.
Right. So, yes, one line crosses 2, and the other cross only 1.
At least once.
Well, exactly once.
Again, here it doesn't satisfy.
okay.
So we need 4 crossings.
Well, that idea
Really,
is
here also for crossing, but all segments are crossed. Here,
maybe if we get exactly 4, that's enough.
No. Because in that case,
This one
As
is
it
for
was, I would say,
yeah, this one is for
That's about
1, 2, 3, 4.
but this one is used.
Yeah, but it's 4.
Yeah, well, yes, you're right.
It's 4, but not
And
this
also
one.
you need to check the direction.
Well,
This axis you need to also.
yeah, positive and negative.
Yeah, we need to check that we cross all of them.
The number
additional
and
condition.
the negative ones.
Okay, so counting is not enough.
Counting doesn't look enough for me.
Yeah.
it should be for different from different thing from this segment from
Yeah.
this one
Yeah.
like positive negative.
Yeah.
If you get the coordinates of the crossings,
Yeah, we could get that. Yeah.
then it should be possible to check where it lies.
It could be
We can just collect all crossings, I guess. As
We have a
points.
set, and then
Then we
of
can
the set,
we can normalize everything to length of 1, and then we should have a set of 4 points, which is the exact set we're looking for.
yeah, something like
Okay, let's try it.
I think that works. If we can configure that quickly.
Oh, yeah. That wouldn't be easy because it should be inside the segment. We can like compute, for example, here it's like a linear function, so it's written ax plus b, so we can determine when it's when b is when x is 0, and here will be 0. But we have this information if for the whole segment. But if the triangle is here I'm not sure how we calculate it. Like this is the same point. I mean, we can calculate these 2 points for this triangle.
Right, but I mean, it doesn't matter, does it? Because if it's completely on one side, then sure, we will count the intersects to the axes up there, and even though they're not actually part of the triangle, but that will be taken care of by the fact that the other intersects don't cross the other axis, won't it? Or
No, not really.
I mean, can you demonstrate the case?
I think the point is we cannot just look at the lines.
Yeah.
We have to limit it to this area we are interested in.
I mean, that shouldn't be too difficult,
Crossing
actually.
should be, yeah.
I'm not sure we need it, but it shouldn't be too difficult either way. So slope, I guess. P1 dot x minus p.
Because this, for example, we have this line. Maybe if we do it like this line. But for this line, we don't have this intersection.
Yeah, I think so.
So we we don't care about the segments because
Yeah.
this one will intersect this line and not this line.
Exactly. So we have a what is it?
How's it called?
Pardon?
What's called this slope? I know the name is like pont in French. The slope.
The angle, yeah.
Yeah. And the other point plus b is when the origin is 0, when x is 0.
Exactly, where x is 0
Yeah.
and where y is 0.
No, not y.
Well, we want both.
We want to check when x is 0 to determine the segment line.
Well, we want where x is 0 to determine this crossing.
Yeah.
Well, let's look at AF. Then we want to get where y is 0 for this crossing.
Yeah.
But maybe that's just maybe we can just reverse this stuff, and that's just this. That will do the exact thing. You're just considering the axis reversed, and then the one you're looking for is just the other way. Maybe there's a different way. Let's just do the first one. So we're going to set off from one point, I guess P1, and then we're going to go this distance, I guess dx and dy. So the slope is dy over dx, not to be confused with differentiation. And then we go times dx. No, if we go by dx. Wait, we want to get to High school math is so far away. So we're going from A to F. If we go by distance x, then we get, do you know?
Yeah. Maybe I can like this. You have like two points, for example, like A and B.
Yeah.
So this is one of the to check the intersection.
Yeah.
So we compute the slope.
Yeah.
So we do like as we done there, like a y minus by all over x
Yeah.
minus x. And then this line should be written something like slope multiplied by x plus b, which would be this point.
And small and lower b is what?
Yeah, lower.
It's the intersection.
Yeah.
Intersection of the y-axis.
Well,
So
we're-
if we computed the computed slope, so
right, yes.
we can compute the starting from one of the points. Like we can replace, for example,
Well, we're solving for, so this is the formula for y, I guess, and b is the offset,
yeah,
and then we're solving for thing equals 0,
yeah.
and so then that means that 0 minus slope times x.
So you have like y equal slope. For example, we take ax plus ay. So we can, this is b, small b. If we compute slope, so we can determine because we have this like function ax plus 2b, which is this. So if we determine the slope, which is a, so we can
Compute B.
yeah compute b.
And b is how,
It's just like changing this, like d is equal to ax. No,
Y means
this is minus. No, something like that. So this is correct. I think this should be minus. Yeah. Is that good?
well, let's just try it out, I guess.
That's okay to me.
Yeah, so b will be equal to y. So if we want to compute b, it will be minus slope multiplied by x plus y.
Yeah, so you're missing the minus, right?
I think minus with the slope.
I'm sure there's, should I take the absolute here? No.
We can do it absolute.
No, I'm not sure.
At least we should.
No, we need the direction, that can't be true.
Yeah, we should keep this 1 1. So 2 2. Like first point.
x1, y1.
Yeah, I mean like should be here point A and then point
Oh, you
B.
want to this?
Start by both points, or we can do AY minus AY. It will be the same.
Is this, are you talking about the names just, or?
No, I mean to compute the slope, we should like start always with the same point. That's it.
Like, if there are 2 points, one should always be the first, one should always be the second.
Yes.
So x1, otherwise the direction will be really.
Yeah, because you asked about the absolute value.
Okay, so then this is okay.
Yeah, this is okay.
Cool. Okay, and this is then the y-axis value of the intersect. And x is 0. Okay, so then this is, I guess, so then I guess we return 0 comma what b. So this is the first intersect, and yeah. So I guess we.
So the second intersect we can like.
Actually, let's just look at this one. So this should actually return as the y-intersect should return the same point here now. No, should return this one. And it does. Let's think of some other points, I guess. So if we go to 1,
1, 1, minus 1, minus 1. So
yes, that's simple. Let's, I guess, print them all. So 0, 0, that's appropriate. Well, I don't know how much much further we want to go. Maybe this is enough already. Okay, so, and the other thing is, I think, just with the other slope.
Or we can just make a point y equal to 0 and determine b. So b will be equal to minus slope multiplied by ax.
Well, sorry, I'm not sure I follow. My thinking was, let's do it b1, b2. So in this case, I think I can just reverse and at least for these cases, it produces the right thing.
Oh.
yeah.
If we checked b, I think we do minus b over a. Something. Because y will be equal to 0, we will have this equation equal to 0.
Well, I'm doing b over, well, minus b over a.
This is the equation of the...
Yeah.
So when the intersection with the line of...
Yeah, we're looking...
this one will... y it will be equal to 0?
Yes.
So then we can check what is the value of x. X will be minus b over a.
But we want the value of y.
No,
we want
of
the
x.
Okay, and
Y is 0.
And y is 0, y is 0. Yes,
Yeah.
correct.
So x will be minus b over a. We have slope.
And
We have b previously.
and b. Okay, we can have. Okay. Then I guess b2 should be minus b1 over. I guess
Over slope.
over slope.
Yeah. Actually, yes.
Well, we'll see if that's ever not the case. So, how far do we want to take this? I don't know. I wanted to have these things normalized. So the question is if we do this here. So if we just divide this by itself, or divide it by its absolute self, then we will get normalized to some, yeah, of course, yes, 1, 1, because we don't actually care about the specific point that the crossing happens. Division by 0.
Yeah, because one time it's 0, 0. B is 0, so you're dividing by 0.
But why did this not fail just a moment ago? It must have.
No, it
Because you did
failed,
not
but we, yeah.
Ah, we didn't divide, right? Okay, fair enough. Okay.
We wanted that to be integer.
Yes, we wanted, no, well, we want it to be 1 or minus 1. That's what we want.
Yeah, and we have this special case 0, 0.
Yeah.
Probably also have to take into account this case when counting the number of triangles that's 0, 0. If it's crossing the origin, it's probably not inside.
Ah.
Yeah, but it considered inside.
Yeah.
I don't know what they consider, but yeah, it's definitely a special
Well,
case.
Yeah, if we cross it, cross the origin.
Well, do they mention this in any way?
I don't think so.
We can follow their example for triangle ABC and see that doesn't cross but comes inside.
Okay, let me just check. We may have, does make sense actually to check the case negative in case we have some kind of sign issues going on, but apparently not. I guess we can also check that if we are going from positive to negative on just one side. Well, we don't want to go sure about that. Why is this an issue? So if we're going straight down, we have an issue, I guess. The slope is infinite. So if dx is 0, then we know that the axis intersect will be somewhere. Yeah, it has to be directly below or above us.
if the x equals that means a and b are the same.
Yeah.
Would be perpendicular to the
So if you draw a line straight down, so here
a and b will have same.
Let me do h. So h is directly below a, therefore the slope is infinite because the difference in x from a and b, so ax and hx are
But
same.
the crossing is at
Exactly.
minus x.
Yeah. Don't depend
right.
on x.
Well, not minus x, it's at x. Yes, so the crossing is at...
That's
okay, let's just do it like this. So the crossing is at a dot x, comma 0. And if it is not, we can go forth and do set calculation and yield set tuple and
you also have the case when it's a horizontal line.
right, and this in this case this will be 0. So if dy is 0, then we do similarly and a dot y, else, and I guess we only need this for here, and we return this one, and I think now we have the issue that we want to yeah, I guess the yield is all fine and well, I guess. Let's just do 2 points. So this is the x-intersect, no, the y-intersect, and here's the alternate case for the y-intersect, and here's the x-intersect, and here's the alternate for the x-intersect, and we just return x-intersect, y-intersect. And I guess we have to do the normalization for this too, but probably we should do it outside. We could do it outside. Wait a minute, is this correct? This doesn't make sense. Why would the y-intersect be at a y0?
Yeah, you mixed it.
Y-intersect equal a dot x multiplied by
Did I mix it up? Should I just revert? Let me copy this and revert. So this is where we were. So this is our y-intersect, isn't it? I think it's just mixed up.
No.
No?
The second point should be the y. So there is 0.
The y intersect. No, I don't think so.
So in the tuple, the first number is the x and the second is the y.
Yeah.
So y intersect should have the y value, not the x, because x will be 0. So this is value of x and this is value of y.
Yeah.
So y
But
is
we're-
0,
I mean,
x is
Maybe it's just a naming thing.
okay.
The way I mean it is that the intersection with the y-axis is at this point. So y is 0 at this point because it intersects y. That's how it's meant. Is that clear? So if you're intersecting here, then y is 0
Yeah.
and x is positive. So the y-intersect has an x and 0 y. No? No?
Maybe it's just a name, yes.
Yeah, I think it's just naming.
We mean y intersect by.
I can make it more. Yeah, I can make it more explicit. I can say intersection with y-axis.
Isn't the y-axis is the
This
vertical?
this is y. Yes, this is x.
Yeah.
This is y. I don't know. I don't have a pretty character for an arrow
but,
upward.
think is in the else, not in the first.
What is the else? It's the same issue. Ah,
But then we didn't compute maybe the B3 yet.
I think I mean it's. Good point. Yes, very good. Yeah, very good, very appropriate. Yes. Oh God. Okay. So actually, what we want is B1 down here, isn't it?
Or maybe it's like very shit. We can even get it outside the if statements, the count of slope and.
Pardon me. Sorry. What?
Maybe like counting the slope and B2,
Yes.
we can make it outside.
Yeah. B1
Defining.
cannot fail. But we need the slope first.
Yeah.
But this can fail.
Yeah.
This is why I think that so this is just for the assertion, right?
Yeah.
So I think okay, the slopes also have to be switched.
The return value is still wrong. Should be.
Yeah. Well, I'm going to. I think I'll pull this normalization out because otherwise I have to duplicate it. So, pardon me. So actually we only need this coordinate, right? Y, let's just leave it at that. And this is just B2. Making everything much clearer, I'm sure. Yes, it's called X, but it's actually a Y value. So, and this is just that. Yeah, the naming isn't great. What should we call it? So this is the X coordinate where the intersection is with the Y-axis. Is there any less stupid way to name this?
Oh, okay, it's just a name.
Okay. Okay, so the X-intersect is the Y value, so it has to be on the right. And we take this formula and we do this. And likewise, for the Y-intersect, it's just the reverse. So the Y-intersect is an X value, and it's at this point, and all bets are off because
Division by zero. Oh no!
So where did I go wrong? Division by 0. Slope dx over dy. Slope dy.
Yeah.
Okay. I switched this one too. Okay. Does this look approximately correct? So if we cross the x-axis, it's at this does. Wait a minute. Right, if we're at x, so here we're crossing the y-axis.
Yeah. Because we have
Yeah,
no.
we're crossing. We're at 0, right? We're on the y-axis. We're going from +1 to -1, and we cross at 0, 0, I guess.
Yeah.
Okay, so it's there, I guess.
So we should be crossing to 0, 0 is y-x and x.
I think it's maybe easier if I just do this.
Yeah.
Still crossing at this. No, yeah, we're crossing at +1, yes. But we're not crossing the. We don't have a y-intersect. An x-intersect in this case.
We don't. Yes.
So, did I maybe make a mistake here? So if we have, dy equals 0, we only have one intersection.
Yeah.
Fair enough. You said yes so quickly. What, are you keeping quiet about these issues, or is this?
No. It just makes sense. We just have one.
You're just waiting for me to get to.
No,
Okay, no problem.
No, I didn't think of it.
Okay. Okay, so this means that, I mean, in this case we only return 1, in this case we only return 1, and in the other case we return 2. Okay, let's just do this. We're calling this the x intersection point, and this we're calling the y intersection point, and they may be meaningless. So if this is the case, then we only return this one, pardon me, y. And I guess let's do this, because having, and if dx is 0, then we return the y, or maybe reverse. I haven't thought about it that much. Okay, so let's think about this. So if dy is greater 0, then this is meaningful. So if dy is greater 0, then y1 is meaningful. So I did mix it up. Makes more sense? No? Yes? Maybe?
Not following.
So if dy is 0, then the... No, oh, okay. So if dy is 0, then we can... Then this is the y-intersect, the x-coordinate of the y-intersect.
You can just return it immediately.
So I could just return it immediately. Very good point. But I don't want to duplicate this logic. I could just pull it out, I guess. Okay, let's do that. Let's treat this as a separate problem. So the y-intercept is at here. And I guess we can also pull this up. And then we're back to our old thing. And we can just return these things without this special treatment. Let's just do, I guess, x-intersect, and so, and all of this disappears to reappear somewhere else. Okay, so the other case, I suppose, is staying the same height but crossing the axis, and this should be at 1, 0. We're staying the same height. We're staying the same height and crossing. No, wait, no, I'm saying this wrong. Yes, exactly. We're not saying, but we're saying the same distance on the left, on the right. We're on the right side. Yes.
Will be perpendicular to the vertical axis.
Perpendicular to the
Vertical axis, yeah. So we'll have intersect in the x-axis.
Right, we don't know how to interpret this. Yeah, we do. Yes, very good. Okay. Now, by chance, these things are all, or not by chance, but just by choice, I guess. I guess we'll do some kind of norm function, def norm chords. So intersections. So for return.
Sorry to interrupt. I think I should leave.
Okay.
To travel a bit.
Yeah. I think we can get this done today.
Next time maybe.
No problem.
Enjoy the
Thank you for coming. So for isect in intersect we do, I guess, isect. In this case we don't know which one is 0, so, and we also didn't, I guess we can create points out of it, so we can do this xy thing. So here then we can do dot x. And do I still have this in a buffer somewhere? Nope. So we take x if x we do x over abs of isect x if x isect x greater 0 or actually not equal 0, yeah. And the y is the same. I guess we do point. So this is the x coordinate, and the y is y. So now everything should be 1, 1. So this shouldn't change anything. I don't know how to get to the end of the line here.
Control E.
Control I. Nope. No, it doesn't work because of the minus signs. But I guess we'll have to live with it. So none of this should change. Apart from syntax error. Okay, I have to put this in parentheses apparently. L0, of course. Yeah. We can, I guess, do the same without the norm, just for comparison. Okay, but they're also points. But yeah, but we can still compare, right? 0, 0. I guess they're not floats, but fine. I guess we should coerce everything to float so that we don't, because the sets have to be the same, right? So just make sure everything is a float.
And
So
then, yeah.
now we get to the interesting part.
Yeah. Okay.
So I don't think we need any of this. Apart from maybe origin. Not even that, I guess. Okay, so we go for, we want all combinations of points, I think. So for, I guess I have triangles here, don't I? Yes. So for A, comma B, comma C in triangles, I want to see the normalized axis intersects for A with B, B with C, and A with C. And I want to put all of that into a set.
Is it add or update?
I guess I can do plus, can't I?
No.
They're all lists. And
And you don't have to do update. Don't care.
yeah. So we get the intersects, and let's just break after the first one. So this is some kind of set of intersects, and the ones that we care about are the I guess what do you call are expected. Let's just call it compare intersects.
Isn't it enough to have 4 different ones? Ah.
Well, it could be maybe.
With 4 different ones, I guess it just
4
works
different
if
axes.
we don't have
0, 0.
0, 0 in there.
Right. Yeah. Okay.
Yeah, if 0, 0, we can like.
We could just remove it always.
Yeah, 0, 0, so it's inside, it's true. Yeah.
And then, yeah, exactly, just special case and say if it's whatever, how they count it.
If len of intersects is 4, then I guess result plus plus.
So now we're
Counting the number of triangles which have all 4 intersects.
So there is
point 0, 0.
the 0, 0, we currently say it's outside.
Yeah.
If it's inside, or I don't know. How
Maybe
much.
we can do if
I don't
then
know either.
intersect equals 4 or point 0, 0 in intersect.
Sure. Yeah. Well,
So if ABC in that.
okay. Let's do it here. And
Result plus maybe.
no. Else, how about this?
That's good.
Really? Key error. Who's doing intersects? Okay.
Maybe then.
No, but it has to be in there. So we have to do something like this. So, I don't know. I think does it have a pop method?
What would we
I think
else?
we can just
It's
do
not an
minus the set.
intersect. Why would we?
Right. If it's not in there, yeah. If it's so if it's not in there,
Yeah.
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 Okay.
Yeah.
That's why I said or.
Yeah, fair enough.
Still the same. Good.
Not completely insane yet.
And we are wrong. Let's try don't counting the 0 zeros.
Oh, this is just... You're that desperate.
Yeah.
Doesn't make a difference.
There's no zeros.
Oh, okay.
Okay, let's just have a look at what the things are. It's not so pretty. How can I make this more pretty? I guess I don't have to make points out of them, do I? Actually, why am I doing this? I know that it's 1 or minus 1. I can normalize to integers instead of to floats. So this is less ugly. So just we can sanity check, I guess, with our test triangle. So the test triangle was the first 2 according to the description.
Yeah.
So
First one should be.
yeah, so let's just print the ABC. And the results, yeah, I think we have an issue.
Oh, yeah.
So
X, Y, Z is true. Should it be there?
pardon?
The second triangle is there.
Yeah, it's true, and it shouldn't be.
Yeah.
Okay. Well, I guess we can look at the intersects for the individual ones. So I guess if result greater, we break, just so we have less noise, or 2. And we're looking for the second one, and let's just do this, print these, and see where we're going astray.
What are you doing? Debugging the second case?
Yeah.
The second case should be outside.
Yes. So the second case has these intersections. So let's see. So this is the, I guess I can do something like,
Are we doing that case wrong actually?
yes. So
It says
it says it's inside. So from A to B, we are supposedly intersecting on top. Yeah, let's call this north, east, south, and west. So we're intersecting on the north, and we're intersecting on the west. Is it plausible?
Shouldn't be this.
So A is at minus 175. B is at minus twice that plus thing. And C is at minus 6, so something like this. So the intersection of A and B is, according to my vague look,
Just this.
it should be the west and north. Is that what we have? Yeah,
A and B.
that's true, yes. So the intersection, okay.
You mean just point A, not the.
I mean, no, I mean point A and point B. If we look at these 2 points, they intersect on the west and the north. So this is A and B,
Yeah.
and it intersects here and somewhere up here. And okay, BC intersects in the south and the east. Maybe, wait a minute, maybe I have it wrong. So Y is negative and Y is negative and B is more negative. No, I have it right. So BC intersects in the south.
Because you can't have something like our triangle looks like.
Only this one will make this and this cross.
Yes.
But it can be crossed by those.
Yeah. Oh God. Yeah. Okay. How do we do this?
Actually, what I meant is you need to consider this where it crosses. Actually, in this case, actually it crosses minus minus. Yeah. For example, this one, this lines.
Yeah.
Actually, the conditions, this line, you need to know it's. You don't know how to. Checking all the crossings where it crosses. For example, here is plus x. For example, is plus y.
Yeah.
Minus y. Minus y. Minus y. So I think all this condition should be fulfilled to find the cross lines. This should be 1 minus this should be 1 minus.
Well, we have that.
We have this.
Yeah.
The problem is we're counting this as one as well.
I mean,
Okay, I don't get it.
yeah. I mean, these are the ones that we're counting at the moment
Yeah.
for this triangle. And this one is. Yeah. So, and if you count them all together, we have all 3 axes. Yeah, we even have 1 extra. Yeah, we have 5. Oh yeah. Okay. So, but in any case, we are covering all every axis. But if we counted only these, because we consider the length of the thing, we wouldn't count this one, we wouldn't count this one, then we would be, then we would see that this is not and this is not.
Can we count like this goes this way, this goes this way?
Hmm?
Can we count like this? Yeah, x increases like this way, this one this way.
I think you just have to check if the crossing that we compute is on this line or somewhere outside.
Yeah.
If it's outside, discard it.
Do you understand what we're currently here? This thing counts.
Quote, it's okay. I didn't get everything, but it's okay. It's not problem.
Well, so what currently it just looks at the whole line until infinity, and it sees this. Yeah. So, and that's the issue. At least that's the way I see it. So you want to...
But how you count actually? Just counting, I couldn't get to the end.
Well, we just collect them all. So
Just combination.
yeah, we just see. Okay, this is so this is 1, 0. Right, this is, we don't care about where exactly it is. We just know it's 1, 0. So this 1. Then we see this thing. So this is 0 minus 1. And then we collect another one. So this is another time. Right? But from a different line. So this one comes out for this line for. So this comes one time for AC and one time for BC. And right, so we go on, and then we just look at the unique ones. And so we see that here this one also happens. And here's the only one that happens here is from the AB line. So this is 0. So this is, let's see, this one is I guess BC, and also from AC. So, and then we just see, do we have all 4? That's what we currently do. Do we have every one of them? And we do. So that's why this is wrong. It's much easier solution.
I think there is.
Yeah.
Probably. But I guess it should be fast enough, this solution.
Well, there was no question of speed, yeah.
Yeah. If we only can count the axis between the segments, so we can solve it.
What I'm afraid of, that actually there are like 20,000 or something examples.
Yeah.
We are just counting 360 as in.
Yeah.
I would expect more, but maybe.
Who knows?
Who knows? Yeah.
You expect 50-50 or something?
Yeah.
Who knows what they're thinking, yeah?
Maybe it's just one example. But definitely, this case we get wrong.
Yeah. So do we want to think about a simpler solution, or do we want to go ahead and see if we can reduce the intersects to those which actually cross?
If we can look at this.
Yeah, so, I mean, just excluding the shouldn't be too difficult, right? We know we only have to consider this intersect if Cx minus Bx is greater
No,
zero.
if just if that number is between those, it's easy. Yeah, it's the same thing. Yeah, sorry. Like, yeah. This one should be between those two, right? Yeah,
And then, yeah. It's not that difficult, but
Yeah, the line intersect is between C line and D line. Here also the line intersect should be between those if it's bigger than
yeah.
So, yeah.
Thing should be between the x intersect between the point intersect and y intersect.
this has to be inside here before we normalize.
Yes. So in the 0 cases, it is always
In this
Still-
case, are
there's
we
always
reducing the number of
we are making another condition, but here we are.
Only have 300, so we
Yeah, it will be
expect
fewer,
less.
yes.
Yeah.
Maybe we have another issue. I don't know. Okay, so for this it's okay.
Not necessarily.
So I think I'm going to have to introduce else clauses. Okay. Well, let's just see. Here we have dx and dy. So if dx greater 0, then the
If we check also dy is equal to also to 0.
well, later, yes.
Oh.
Right now I'm thinking of, is the y-intercept valid? The y-intercept is valid, I think, if dx is greater 0.
No.
No?
Why? D could be
Maybe
further
we
to
can-
the right and it's still valid.
Maybe we can start with this condition. If dy equal to 0,
Now let's just think of it completely separate from that. Well, how many cases do we have? So the y, and we have this case, and we have this case, and we have this case. So, and the only valid case is this. So, I guess, well, let's just check if, okay, if the x is positive, and the x is negative. So if we have both negative and positive, then we know there's an intersect.
For which case? For the horizontal line case?
Yes.
Yes.
Let's just do that. But can I?
x multiplied by x2 less than 0.
Ah.
So we make sure that are both in different sides.
Yeah.
So
So what's the formula you said? x2?
This x multiplied by this x is less than 0.
you
It
multiply.
means like
It's always negative, yeah. Very good, very good. Very good.
I can.
Okay, so this means that y-intersect is okay. And this means that the x-intersect is okay. And so if the sum intersect,
But this doesn't solve it if one of the points is on the axis. Because then 0 multiplied with something.
0, so I have to do less than equal, I guess.
Yeah,
You mean at the same level or
yeah, less than equal. Less than equal.
Okay. Okay. Is this correct? So this is a FD.
Oh. So maybe they can be both on the same side and would be equal 0, and we count it as intersection. You see? For example, if it's something like here and here, and it will be equal to 0, and then we count y I is okay. So, I mean,
Yeah, see it comes.
I mean something like this.
Pardon?
Here we said if one of them is 0, we also count it as true.
Yes.
But it's if
Counting
one
wrong
point,
ones, yeah.
yeah, if point is on the x and there is no intersection. Oh no, actually the intersection is here, so it's okay.
But not with the other axis.
So
Yeah.
But
I counted only one intersection.
yeah, look at the right thing. The black one is.
Yeah.
If you do 1 point on the
One
axis.
point and 1 point.
Yeah.
So intersect is okay.
Yeah.
I think so.
Yeah.
So that's what I said. Maybe this is
Yeah. Okay, so if xi okay, I take this one, and now I need to. So I'm very tempted to use generator. Does everybody feel comfortable with generators?
Yeah.
Yeah. Because then down here, all I have to do is if y y-intersect is okay, then yield the y-intersect or the x-intersect, I guess. Okay. Auf ein neues. So the very first, I guess, axis intersects AB. What the? Why is this?
Maybe because it just returns nothing.
Oh no, yeah, I never set this to false in the other case.
Ah, yeah.
So I guess I just do this. What's the issue now? Oh, there's no issue. It's just confusion because of cells being too large. Okay, let's reduce the number of prints. So still incorrect.
still at the second part.
Yeah.
Second term.
Okay, so I guess I just reverse to... How depressing. Okay, what does it say now? It says that... What do we have here? So now it says AB intersects in the west, which is true. It says that BC intersects in the south, which is true, and it says that AC intersects in the
East.
in the north. It says it intersects in the north and in...
Which example are you looking at?
Oh god, I'm sorry, yeah.
It's like, yeah.
I was looking up here, pardon me.
Me too.
Okay, let's highlight it. Let's highlight it. It says that AB intersects in the north, which is wrong.
Yeah. Wrong.
It's this example, isn't it?
Yeah, yeah, yeah.
Intersect in.
Yeah. This
in
should be
east.
the second.
Should intersect in east.
Yeah.
Should be -1, 0.
No, yes. Which is the west.
Yeah.
Maybe it's a mix-up. I mean, we had all intersections before. We know, I think we did at least, but we didn't exclude. So I hope, I mean, we could just yield either way. So we could just set this to always true, and then we have the previous version. And now we can see whether or not we at least have the intersection in one case. So
we kept the false one.
yeah, probably.
Yeah. We have the -1, 0, which is the west.
Okay.
But we kept the 1, 0.
I guess then, without understanding why I did what, I'll just switch around and hope for the best.
Oh. Okay. Nice. Nice guess. Yeah, but see why this one is here and this one is here shouldn't be counted.
Yeah, shouldn't be counted because, yes, there's one axis missing.
And there's the false.
It's false.
Oh, okay.
Highlighted in everything. Okay, then I guess let's try again.
We have less, that's expected.
Cross fingers.
Still wondering why it's so low. Maybe?
Yes! Cool. Yes! Now we can see the phone.
Yeah, oh god, this is going to be so
Embarrassing.
Yeah.
That's very hard work.
Yeah, this is.
Not for me, for you.
Oh god, I barely.
But our solution is not that long.
I guess we can simplify the code.
I mean, yes. This is very. I don't. Maybe this can be done in much less code, but this is kind of.
Yeah.
I think this is okay.
Yeah.
Let's just ignore everything else up there. Pretend it never happened. What is the... I'm going to go by the thumbs up. So, yeah. sure.
Which language? AP or
Using the fact that a point lies on the interior of a convex polygon if and only if it lies to the same side of each line segment when viewed as a path. K. There's a language called K. A point lies on the interior of a convex polygon. What is a convex polygon?
Some things that's connected. If you make a path out of it, like directions,
Yes.
the point needs to be always on the right or on the left.
Exactly.
I don't know how to compute it. That's how I understand it.
Makes very much a lot of sense, yeah.
And this also works if it's not a triangle but this shape or whatever shape.
I just says a polygon, right? Yes, general, yeah. Very good.
I couldn't get your point.
You make this. It's not my point. It's
Yeah,
You walk around the
whatever
line
this guy.
and you see it's always to your right.
Okay.
You walk on the triangle, and if the point is always to your right, it's inside. In this case, you walk here, it's on your right. You walk here, it's on your left.
Yeah.
Okay.
Not
Yeah. I think this is a different. This is a different formulation of what you had written earlier with the.
Those walking.
Oh, this is the sellotape.
Because I was moving the lines like this.
With the perpendicular thing, right? But maybe it's. I mean, it's in principle it's similar.
But what's this?
Well, the idea is good.
Yeah.
Let's just give him a thumbs up for that.
Thumbs up from Euler.
Okay, here we have. Oh god. Okay, so I think
Cross product.
just check this. Cross product of what exactly? So
A1.
what is he constructing here? So if all cross products are equal to each other. Ah, no, greater than 0. So these are all Booleans. So they're either all true or they're all false. And then the solution is then he increments.
What is he computing? I don't get it.
He's
A1 times B2. That's
It's
X
like
of first.
yeah, I think there is
so this is the x coordinate of A and this is the y coordinate of B.
cross product.
So I just do cross.
And is other determinant or something like that also named, but I'm not sure why it's.
Broken. Okay. Yeah. Okay. Then this is a vector that is perpendicular to the other two vectors.
Oh.
It doesn't work. It can't be.
Yeah.
I mean, it could be perpendicular to the vector formed by the 2 points.
Yeah, I remember that. It's like the determinant to a paraplan. You take like 2 vectors and you do the cross.
You lost me at hyperplane.
Yeah, because the triangle is an hyperplane in the Cartesian.
Sure.
All of this. I learned all of this.
Yeah, I was 14 or 15 when I last looked at this stuff. Maybe. Not quite. What you're saying determinant. So what is a determinant?
Yeah. So that's the cross product. So if this is the first, like this is x, y of the triangle.
Well, they have to be a bit different because the walking around the path, your orientation changes all the time, every time. But this is like always the same coordinate space. It's like always assuming x and y, like this.
Yeah.
I think. So, but okay, let's see. So, but he's just checking, is this greater than 0 or equal to 0? So if it's less than 0, what does that mean? What does a negative determinant imply? That means, actually,
What's the meaning of it?
no, I mean, not necessarily. It can be, all of them can be negative and then it's also a solution.
Yeah. This is checking if all negative.
Yeah. Okay, well, let's try and
Apply Euler's formula something.
I think this is a different approach. So area of a triangle is this. Yeah, but you have to construct the right angle triangles, I think.
Origin is the area of the whole triangle equal to the sum of the versions of the triangles. Ah, I get this one.
Apply Heron's formula to the triangle.
That one is actually nice. So what he does is he computes this triangle.
Ooh!
That's the point.
Oh,
He
yeah.
creates this triangle, and this one.
Yes.
Computes the area of the three.
Yeah.
And if that area is the same as the big one,
Yeah.
it's inside.
Yeah.
So it's also very tricky.
Well, I think it's less tricky than what we did.
Yeah, definitely less tricky.
This is approximation, is not like is the calculating area.
Yeah, we may have to deal with floating point or something.
Yeah.
Maybe. I don't know.
Is this
Actually, no, if
correct?
we do the squares, if we are always in the squares, we should be fine, yeah.
If you do leave the squares.
Yeah, never do the... Yeah.
Yeah, but yeah.
This is a good approach. It'll be easier to do this.
Yeah.
What's this S? What is S?
So the side where S is the
Ah,
semi-parameter, which...
So this is the approximation. So we replace.
Why approximation?
Not sure.
But I didn't know about Heron's formula, actually. I thought you could only calculate the height of right angle triangles and the way you get the height.
Yeah. Height multiplied by base over 2.
Yes, that the area of a triangle, and the way you get the area of non-right angle triangles is just to deconstruct it into right angle triangles.
Maybe you can look
But-
for Wikipedia.
And I guess that this is something he's doing.
Is that what that does? Really? Maybe.
He's saying he's using that as the formula to compute the area, and then he's doing the thing.
Yeah.
S is source, yeah.
Maybe maybe reformulating it.
Here on file.
I'd still like to understand this.
This is very nice solution.
Yeah. Well, I think if we understand what the meaning of determinant is,
Maybe you can search in the forum if there's another post that uses the same method somehow, but has some more text than this one.
Yeah, let's just do cross. So letting ABC denote the corners of the triangle. I look at the lines A0 and BC. Yeah, origin to and BC. The extension of A to the origin must intersect BC.
Still using the same cross product.
I don't know.
Doesn't help.
Let's look on maybe this one. Used cross products to find which side of an edge is the which side of the edge? Okay, apparently this has something to do with the sides of the edges. If the origin is on the same side of all edges, the origin isn't. Yeah, well, that much we have.
Yeah.
So if the sign of the cross products is all the same, does that imply that this side of the origin is also? Is that correlate? Is it the same thing? This is the cross product, I think.
No.
Maybe.
I just found the Heron like translation why.
Yeah. I'll just accept
Because
this.
it's first time I see how we compute that.
But
So, but then this is the same solution as the first one we saw with the path. He's looking at
right.
which side this thing is on, right? It could be on the left or the right, or on this thing. And then he checks.
Yeah.
If it's always
This is
the same.
exactly the same. I mean, yes.
It's always on the same side here.
But what we can read out of this is that it has something to do with the sides. So
Yeah.
the cross product implies something about the side that the origin is on. Okay, I first discarded all triangles which didn't have both negative and both. Well, I guess that's now okay, sure. Then I calculated where each of the three lines would cross the x and y. No, this is what we did.
That's exactly what we did, yeah.
Yeah.
Without the filtering that he did before.
Yeah. Maybe this would save us from, maybe this pre-filters some cases that we had to deal with, I don't know. Okay, what about, so what do we have here? Are less than pi. What the, who? Okay. I mean, I'm inclined to not even give this consideration, but okay. Now draw. Okay, I draw these lines, sure. If O is inside the triangle, the angles of this are all less than pi. If origin is outside, then one of them will be greater than pi. I suppose. Yeah. Yeah. You get it? Nobody cares. You construct this triangle and this triangle and this triangle. I guess this one is pretty thin. There's another one here. And then you look at the angles here. So this angle and this angle. So if it's outside, then the angle will be greater than pi. So let's just take an example. It's outside. And here. So here the triangle, this one, the angle he's looking at is this. And it's greater than pi. So if any one is greater than pi, it's not the origin, it's the outside. No? It depends. I mean, you have to. You have to look at the. You have to construct the angle in the right way. So the origin has to always be the second one.
I actually prefer our solution to this one.
Maybe. But I think it's.
But yeah, the other one is pretty nice.
Yeah, I found something about the cross product. Said, okay, I will read. Define the vectors like if we have like a point P,
Yeah.
and we should define the vectors A, B, B, C, and CA, and the vectors AP, BP, and CP. Then P is inside the triangle formed by ABC. Only of all cross products AB multiplied this all cross product point in the same direction relative to the plane. So what I say, the determinant, if you calculate if it's positive, so it's pointing something like this. If it's negative, it's pointing.
This is the whole right angled.
That's why we should check all say
Right. This
all
is,
have the
is this
same.
the right hand rule, I guess?
Yeah.
Yeah. Okay, so yeah, the determinant is this guy, I guess.
Yeah,
And
exactly. Yes.
yeah, okay. And if I huh.
Maybe if B is in the other direction, so it will be point negative. So should like all
Yeah,
them
exactly.
have a positive determinant or negative determinant to
So-
have that point.
So this is exactly what the
yeah.
other thing. So I'm going, I guess, here, and it's on the right, and I'm going here, and it's on the right, or it's going up. I guess it's going out of here, and now I'm going here, and it's also up. So it's pointing up, which means that it's to my right. It means the same thing, right?
So I will cross product should be AB and AP.
Well,
AB and let's
I mean,
say
it doesn't matter.
AO.
I will just pick this way because it's easier for me, I guess. So if I do AB and AC, and then it points upward or out of the thing. And this is the same thing once I go down here, once I go here. But let's take the counterexample. No, this is the counterexample.
Yeah, this is the kind.
Okay.
Yeah, the vector is AB and AO, so not like between the
points, but towards the
Yeah.
origin.
yeah.
Okay. So
Maybe if we like do something like that, if this is like, for example, this is A, B, and C. So we should have AB cross product with AO, and then
how do I read this? So I'm
thing, for example, AB is pointed something like this, and AO is something like this.
So it will be, yeah, this this side. Yeah.
Okay.
And then BC multiplied by BU. Okay. Now BC and then BO will be this. So should take you right. And then if so it will be
Okay, so the black is the out.
okay.
So let's just do the same thing as we did here. So this will be here. So the first one, I guess the green, is the green always to the origin, let's say? Or just for simplicity?
I think the first vector should be always should be the red one,
Okay,
and the second one should be the green.
okay, so,
No, maybe if you.
well, it doesn't matter, as long as I keep it like this.
Okay.
Then it
So
should work.
the first vector is the green one.
No, the red one. Because
Oh no,
AB.
because AB. Okay.
So it doesn't matter as long as I keep it consistent. So the red is the first one.
Okay.
The
The
red
red
is
is the first
The
one.
green is to the origin, and now we're pointing outward. Okay, so the red is to the first one, the green is to the origin,
And we also are pointing out. So till now it's okay. So now from CA
and to the origin. So yeah, exactly. Now I have to. Now I can't just. I have to go like
exactly. Yes.
Yes.
Yeah.
This is the point.
Yeah. This means that it's going. I changed the direction from into to from out of to into. So it must be.
Yeah. It must point to the other side of the plane.
So the thing, what they compute is this point to the left or to the right of some vector?
Yeah.
And they do it for all three vectors.
And if it's always the same side.
Then yeah.
I learned a lot today.
What?
This is very interesting.
Yes. Very interesting.
I think this might be useful at some point.
I have to leave.
Yeah, thank you for coming. Very nice to have you.
Thanks a lot.
Thank you for coming.
Can we help you something?
Simplest thing would be to clean the board.
How does it work? Just use the
If you need to, you can. If you need water,
Alright.
you can do that.